Welcome back to our chemistry channel. Let's start today's class with some riddles. First, a man was outside while it was raining. He was without an umbrella or a hat, but he didn't get a single hair on his head wet. How could this be? It's because he was bald. The second one, what gets wet while drying? It's a towel. The last one, what has many keys but can't open a single lock? A piano. Why do you think that fireflies are called fireflies and bicycles called a bicycle? There has to be a reason behind it, right? Fireflies look like fire and they fly so they are called fireflies. And bicycle, bi means two. Since it has two wheels, it is called so. Similarly, in carbon compounds, not all compounds can be called the way we like. So, to name carbon, there are some rules. In carbon, 1 stands for meth, 2 stands for eth, 3 stands for prop, 4 for but, 5 for pent, 6 for x, 7 for eth, and so on. If a carbon compound has 1 carbon atom in it, then it starts with the prefix meth. If there are 2 carbon atoms, the earth, and so on. Let's take butane with formula C4H10. For example, it has 4 carbon atoms. It has 2 different carbon structures. One is straight, another one is branch. We see that it has 2 different structures, the same molecular formula. These compounds which have same molecular formula and different structures are called structural isomers. Carbon can also form ring structures like cyclohexanes with molecular formula C6H12. It looks super cool? Yeah. All these things are about the structure of carbon compounds. Now, let's see about carbon's reactivity status. Carbon is a very friendly element. So far, we have only seen about carbon-hydrogen compounds. But carbon also forms friendly compounds with many other elements such as halogens, oxygen, nitrogen, and sulfur. All these elements can replace the place of hydrogen in carbon compounds. These elements are called heteroatoms. These heteroatoms, which are present in the carbon compound, give the compound a specific property. For instance, let's take carbon disulfide CS2. This sulfur gives this carbon compound its own property. So, these atoms or sometimes group of atoms are called functional groups. We can distinguish the organic compounds using their functional groups. Here are some functional groups which you have seen in our carbon compounds. We are going to see the functional group of 2 heteroatoms. First heteroatom is a group of elements called halogens, which are present in 17th group in the periodic table. All these elements have the valency 1, so they can be made as a substitute of hydrogen. So, the name of this functional group is haloalkane. Next, let's see the functional groups of the heteroatom oxygen. Here, the name and property of the functional group differs by the way that the oxygen is bonded to the carbon atom. Let's first look at alcohols. Yes, that's right. Alcohols are compounds of carbon. If a carbon compound has the functional group OH in it, then it belongs to the alcohol functional group Similarly, CHO for aldehydes, C double bond O is called ketone, COOH for carboxylic acid. You will learn about them in detail in your higher classes. Next, we are going to see about a really important topic. It's called the homologous series. Before that, let's see an illustration to understand this easily. Let's say there are 3 snakes. One small, another a medium sized, the other a big one. Even if they are of different sizes, they are all snakes and have the same characteristics such as scary looking and scaly and so on. It is similar in carbon compounds. Let's take the functional group alcohol, that is OH. Let's take 4 alcohols: CH3OH, C2H5OH, C3H7OH, and C4H9OH. All these are alcohols, even though they differ in size and number of carbon atoms. They all have similar chemical properties. So all these alcohols are members of the family called the homologous series. Now, let's see a few properties of the members of the homologous series. As I have told, they have similar properties. And here's another property. If you have observed keenly, the successive member of the homologous series differed by a CH2 unit. Let's take alkanes. As I have told, they are carbon and hydrogen compounds, single bonds. The first member of this homologous series is methane. Yes, CH4. Next one is ethane. CH3, single bond, CH3, whose molecular formula is C2H6. You will observe that they differed by a CH2 unit and also by 14 MU. Let's take another example: C2H5OH ethanol, C3H7OH propanol. They belong to the homologous series with a functional group called alcohol, as we saw earlier. See again, there is a difference of CH2 between them. If you take CH2 from propanol, then you will have ethanol. Now, why don't we try this for alkenes? We know that ethane is the first member of alkenes. CH2, double bond, CH2 with molecular formula C2H4. The other compounds of the series are C3H6, C4H8, C5H10. Do these differ by a CH2 group? Yes, of course, they do. All the succeeding members of the homologous series. That's all for today, guys. Meet you soon again in the next video. Until then, bye from your rest of us. Bye.